Okay, so we are
live.
live. I hope. Let me just check if my audio is clear or not.
Yep.
So my audio should be clear and we are live. Let me go to the hatch window. One second, I'm just checking if the stream is working properly on the YouTube's thing or not. Okay, so my audio is echoing, yes.
Now my audio should not be echoing and we are ready to start. Cool. So it's time we can start. Welcome everyone. Today I'm going to show you guys how to build a Voxel Painter app. So before we begin, first of all, because a lot of people might not know what a voxel painter is, so what I want to start with by explaining what a voxel is. Okay, so I have the final output open here. I already have the project built. I will show you, I will build the whole project from the very beginning and you guys can follow me along or watch the video, rewind any step that you miss and rewatch the video and just build it whenever you want. Okay, but you can see I have the code of the project and I have the design ready. There is nothing in the design, but when I run the script, the project starts working. So before we begin, let me just show you what the project is and then I will explain to you what is the voxel painter. Okay, so let me run the script. Now this might take some time to run. This final project's link is available in the YouTube videos description. So if you guys check the description, the very first link is the final project link. You guys can click on the link and see for yourself how the project runs. Okay, so as you can see, my project is running here and now you see there is a grid and as I'm moving around the grid, as I'm looking around the grid, there is this small red box that keeps on following me. Yeah, and see, if you click anywhere, a box gets added to the scene. Now what I can do is I can move around and I can add another box anywhere I want. I can add more boxes, and what I can do is I can build a 3D object by just following this project inside this project. So you can see, like, I'm just building a random 3D object. So all I have to do is I just have to look around and move around to the proper position I want, and I can build my own 3D object. So you see, I just built a small, simple, just a collection of boxes that are interconnected with one another. But you can use this. So voxels, okay, now let me start with what a voxel is. So voxels are volumetric pixels. Okay, so let me explain what that means. Pixels are small dots with which your entire screen, any digital screen, is made up of. So any 2D screen that you see has very small dots, and I think there would be some noise coming around. I'm really sorry about that. I think it will go away in a minute or so, but cool. So any digital screen that you see, it is comprised of very small dots. They are called pixels. So whenever a new phone is released, or whenever a new laptop or a desktop is released, or a new monitor is released, what happens is a lot of them, in their tech specifications, they advertise how many pixels they have, what is the screen resolution, what is the pixel density. Some of them say 300 ppi, 300 dpi, and 1920 by 1080 pixels. So those are basically the number of pixels that are there in a screen. So a small screen of your phone, like my phone has this size of a screen, but it is made up of 2500 pixels this side, and it is made up of 1080 pixels this way. So it is basically made up of 2500 times 1080 pixels small dots my entire screen. So what happens is, in a 3D space you don't have pixels. Yeah, you can't have pixels because it's a 3D space. You have 3 dimensions. You have front, back, left, right, and up, down. So we have, in place of pixels, we have voxels in a 3D space. It's basically, rather than a dot, you can create any object in a 3D space using very small boxes. Like you can create any picture on a 2D screen using small dots of different colors and combine them, and you will have a picture or whatever you're seeing on your phone screen. Similarly, a voxel is a volumetric pixel. It's basically a very small box, and any 3D object can be broken down. If you want to make a 3D object, any 3D object, you can make them by combining basically very small boxes together and attach them together, and you can place them properly wherever you want, and you will end up with whatever 3D object you want to build. So now these, right now what you're seeing here is not a very small box, it's a very large box obviously, but still using this we can make like good like in earlier days in the 90s and 80s, there used to be 16-bit games, 8-bit games where the characters, you know, would have very square, like pixelated shapes. So similarly you can make low resolution 3D objects using this Voxel Painter app. Okay, so as I told you guys, we have the final project link is available in the YouTube video's description. You guys can open and go through that as well. For now, I'm going to start with a new project. So I'm opening up a new project. You guys can open up a new project by just simply going to HatchXR.com, and I think I should close I have closed the previous tab. Fine. So this is the HatchXR window. You guys can open up the HatchXR window by just going to HatchXR.com and then clicking on the new project button. Okay, so what we are going to do now is I'm going to show you how to build this Voxel Painter app. I'm going to try to keep it as small as possible because generally my videos tend to be longer. So let's try. I'm going to try to complete this in the next half an hour, and I hope you guys stay till that and learn something. And also, I think I have also added the Discord community link of HatchXRs in the video's description. So there, me and all of my teammates who have built the product are available, along with all the other creators who are building on Hatch. So you guys can join the Discord community also and discuss with others what they are building, what you are building, whatever questions you guys have, you can post there, and we resolve doubts and any issues you're having through our Discord channel as well. So you guys can join that as well. Okay, so this is a blank scene. So whenever you open up HatchXR.com and open up a new project, you end up with a scene that looks like this. Now there is nothing in the scene right now except for a box, a sphere, and a cylinder. Let me just delete all of these. So I'm going to delete the ground as well. So I am left with an empty space. What I will do is, first of all, I'll change the background color to white. So what I can do is, you will see that there is an FX button here. Click on that, and there is scene background. There is a blue color defined here. Just select, not exactly white, just make it slightly off-white, gray, and good. So now I have this white scene, white colored scene. And what I'm going to do is this grid here, I don't want this grid. So I can turn on and off this grid by pressing the G button on my keyboard. So now we are going to start by placing a very small box, a very small plane. So I'll tell you why. So we are going to first of all start with adding a small plane. So you see, if I go to the toolbar on the top, it says basic objects, click on that and click on plane. And you will see that a plane has been added. Let me turn on the grid for now. Cool. So there is this blue colored square on my screen. Okay, let me place it at 0, 0, 0 for now. Now I can double click on the plane and I'm closer to the plane. So this is my plane. Now what I want is, I want this plane to be of the same color as the background. Why? Because what we are going to do is, we are basically going to make an invisible ground we are going to basically clone this plane. Okay, we are going to make a 420 cross 20 grid of this small plane. And then what we are going to do is whenever my cursor enters any of those plane and we click on any of those planes, then we add a box. And then we are going to say that whenever my cursor enters any of the faces of the box, then also add a box. Keep on adding boxes whenever we click on anywhere in the scene that has a plane or a face. Okay, so let me show you. So I have this plane here, and what I can do is I can, let's say, rotate this. Yeah, I can rotate this by 90 degrees, minus 90, and now it's like it's the ground. See that? It's simple. Let's reduce its size. It's 1 cross 1 is large, 0.5, 0.5. I want small boxes. Cool. So I have this small plane here, and what I can do is I can make its color. So my background color was D6, D6, D6. Copy this color and paste it in the box. So now I have this plane that has the same color as the background. And what I'm going to do now is I'm going to duplicate this, and in the properties, in this second plane properties, I'm just going to go to its materials and select wireframe on. Okay, so what I'm doing is basically I want this grid to be visible. Okay, you see, like right now there is this grid. This is my plane 2, this diagonal that you're seeing. See that? And plane 1 is this gray colored box that you're seeing below. Okay, so what I'm going to do now is plane 2, I don't want any shadows, no casting shadows, no receiving shadows. And same for plane 1, no casting and receiving shadows. And select plane 2, I'm going to make it black color so that the wireframe is visible. The reason I'm adding the wireframe is when I clone these grids, when I you saw that when I ran the project, in the completed project, there was a grid of squares. This is what that is. This is the one square of that grid. Okay, so we are going to use this one square and create a grid of 20 cross 20 squares. Just simple as that. So okay, let's go back to plane and position it at 0, 0, and we are going to make plane 2 a child of plane. Okay, so now let's come back to our light, and I'm going to make this an ambient light. So when I make this an ambient light, what happens is, you saw for yourself, the object, actually what I can, yeah, fine, ambient light is fine. Cool. So now I'm just going to move my player back so that we can see what's happening. I'm just going to move the player back. Now first of all, let's start by coding to create a grid of the planes. Okay, so I go to the code window, and here I have this one grid. Let's go start coding. So I'm just going to first of all increase the size of my screen so that all of you are able to see what I'm coding. So first of all, I'm going to create a function that will help me clone this object. So I'm going to say function create box, create plane. Okay, so function create plane, and what do I want to happen in this function is that I'm going to clone this plane. So what I'm going to do is, in the utilities here, there is a clone object function. So click on that, close this black box. You can delete the without a callback segment, and you have hatch clone object. So this is a function. So you can see for yourself, hatch.clone object, and then here you define what object do you want to clone. So I want to clone what? I want to clone plane. Okay, and what do you want to happen once the object is cloned is going to be written inside this here in between line number 4 and 6 right now. Okay, so before we go ahead, so let's just do it this way. So I'm going to start with a for loop. For let I is equal to 0, I less than 20. So let's start with 10. So I want to clone my plane 10 times. 10 cross 10. I want to make a grid of 100 squares. So I is equal to 0, I less than 10, I plus plus. We are going to make a nested for loop. So inside this I write again another for loop. Let j is equal to 0, j less than 10. I could have created two variables to define the number of the length and width of my grid. That would also be easier to, that would also be good to do. But this, and then so this what I'm saying is I'm creating a nested for loop that, so when I is 0, j is going to go from 0 to 10, and then I will become 1, and then j will again go from 0 to 10, and then I will become 2, and then so on and on. So this for loop is going to run with for every combination of I and j whose values are going from 0 to, well, I said less than 10, so till 9. I can make it equal to 10, so it will make basically a grid of 11 cross 11. That's also fine. So yeah, and then here I say create plane, and what I'm going to do is I'm going to pass on these values of I and j inside my create plane. So now the reason I'm going to use these I and j values is because that I and j values are going to tell me what the position of a square is going to be whenever we are cloning the square. Okay, because every square that we place in that 10 cross 10 grid is going to be having a different position. So here we define its local inputs. I'm going to say u and v. So what I'm going to do now is very simple. We can just say so whenever we're cloning this plane object, it's being given a clone object name. Okay, so cloned object is the name, temporary name. So I can say cloned object dot set x to what? To, let's say, I. Okay, and cloned object dot set z to, let's say, j. And let's run this. Let's run this. We have written some amount of code, and let's see what this does. So you can see nothing is happening. Okay, my mistake. I'm so sorry. I should have said u and v here. And I run the code again. So now you see I have a grid of squares, but problems. First problem, the squares are not attached. And second problem, I am looking here, but they are offset. So we have to bring the entire grid to our center and reduce the spacing between the grid, between each of those squares. That's simple maths. So I'll tell you what we're going to do here. So see, I is going from 0 to 1. The value of I is going to be 0, 1, 2, 3, 4 till 10. The value of j is going to be 0, 1, 2, 3, 4 till 10. So basically the position, when we are saying u and v, so this position is 0, 0. This position is 1, 0, 2, 0, 3, 0, 0, 1, 1, 1, 2, 1. And the size of these squares are 0.5. Remember, we changed the size of the squares to half, 0.5, 0.5. All we can do here is say 0.5 u multiplied by 0.5 and v multiplied by 0.5, and one problem should be solved. The squares would be back together, would be sticking together now. See, okay, one problem solved. Now let's offset them. So all we need to do is, so this is 0, right? And that's 10. So we can say x may minus 10. Multiply this and say minus 10 or minus 5, because we only want to move it halfway across. So minus 5, and same goes for v, minus 5. Let's run this. So now what happened is they all moved to completely to the left side from the right side. So my numbers were wrong. This is supposed to be half of 5, 2.5. 2.5. And then run the script again. I'll tell you why 2.5. So if you were actually calculating the numbers, you would see that the x position of any plane is going to be its index I minus 10, I minus 5. So I minus 5. If we want everything to be centered properly, I minus 5, and that multiplied by whatever scale we have given it. So multiplied by 0.5. And this becomes basically 0.5 times its x index minus 2.5. Okay, and then same goes for z as well. So now I have this grid of squares. What I want to do is, whenever, see my cursor, this black circle, whenever it moves over, let me see if the stream is perfect, going fine. I'm just checking the stream. So cool, the stream is fine. Awesome. So what I was telling was here, if this black circle is my cursor in the VR space, in the 3D space. So what I want to do is, whenever my cursor enters any of these squares, I want basically an indicator that my cursor has entered one of these, which square my cursor has entered, and I want that indicator of red box, because that will tell me where am I going to add a voxel, right? A box. So let's go to the design tab, and what we can do is, first of all, I'm going to create a small box. Now go to a plane, and here see detect cursor events. This needs to be turned on for my cursor to be able to detect, but for my computer to be able to detect when my cursor is entering inside a square, inside a grid. Okay, so make sure you turn this on. Now go back to your box. Let's position it at 0, 0, 0. And remember, the plane scale we changed to 0.5, 0.5. The size 0.5 meters. So let's change the box's dimension to be 0.5, 0.5, and 0.5 as well. Okay. And what we are going to do is, we are going to make its y position 0.25, half of its height. Okay, and let's place it very far behind, minus 100. I don't want to see this box right now. And what I can do is, let's make it red color. For now, let's go ahead with red. And I also want to reduce its opacity, because this is not the final box that we will be adding. This box is just an indicator of where my voxel is going to be added. Okay, let's go back to the code. Now what we are going to do is, we are going to say, go to our events and select, go to our cursor here, cursor. My head might be obstructing cursor. When you click on cursor, you get on entered object, on left object, and on click at object. So a cursor can enter an object, leave an object, and when a cursor is placed inside an object, it can be clicked. Okay, so these are 3 different events that are being detected for a cursor. So I can say on entered object, and on entered which object. So we need to say, this will define which grid, which square my cursor is entering here. So what I'm going to do is, actually I'm simply going to cut this line of code from here and attach this event inside each of these cloned objects itself. So what this does is, if I say here cloned object, so every grid of square will have its own event of cursor enter. So for every square, whenever my cursor enters that, it will detect automatically. We don't even have to create any new array or any new variable here. I can say, so what did I do? I said inside this create plane, hatch clone object, clone the plane, and inside the clone plane, after setting the x and z position, I'm saying whenever cursor enters the clone object, what I'm going to do is, I'm going to say box. So I have this box dot set x to clone object dot get x. Easy. And box dot set z to clone. So let me just see. Okay, I think I will, yeah, this also should be visible. So box.set_z to cloned object dot get z. Okay, so now what will happen is, see, let's see the example. Let's see what's happening in the project. So run the script, and I have a grid of 11 squares here and 11 squares here. So 11 by 11, that's 121 planes, 121 squares. As my cursor enters any of these planes, see, as my cursor enters any of these planes, what's happening? That red box that we created, that transparent red box, it's moving to that position of the square. So see, we are saying set x and set z. We are not saying set y. Why? Because, okay, we are not doing set y because we already placed the original box just above the plane while we were designing. 0.25, we placed its y position to be 0.25. So we might have to set the y position later on. We'll come to that why. But for now, we don't need to, because the original box already had the y position there. Otherwise, what we can let's just do it here. So box.set_y to, now all of these planes are face up, right? So whenever my box has to be placed on these planes, its y position needs to be 0.25 units above the plane's y position. That is why in the design mode also we wrote its y position to be 0.25, because we know the y position of the planes are 0. So cloned object dot get y plus 0.25. okay, so do this, and this is the same. So nothing is going to change in the output of what we are seeing right now. We'll still be able to like move around. See, I'm able to look around and yeah, watch all of these. Okay, cool. So now what we can do is, let's add the function that whenever we click on a box, an actual box gets added in that place, in place of that red box. Okay, so first of all, so here's the trick, because what we want to do is, whenever we add a box, we want our cursor to be able to detect whenever my cursor is entering the front face, each of the faces, so that we are able to add more boxes. So the way we are going to do this is by not actually creating a box, but by placing different planes to look like it's a box. You will see. So see, how many faces does a box have? How many faces does a box have? A cube. A cube has 1, 2, 3, 4, 5, 6. So 4 sides and top and down, 6 faces. We don't need the bottom face because we don't want, right now I'm only going to construct my voxel painter on the top of each other, so not bottom. So I'm not going to add a bottom plane. So we basically need 5 squares to create a box. See, I already have this plane. I'm going to clone this plane. Okay, and I'm going to delete the plane 4 inside of it, and its rotation to be 0. Now this plane here has yeah, so this, I have a plane. Let's change its color. Let's make it red color. Okay, so this is one side of a box. Okay, we can clone this and rotate this in Y to be 90 degrees, and that will be another side of a box. Let's make it blue in color. So blue color would be this. Cool. So it's a blue colored face, and what I can do is I can clone this plane 3 again, and then rotate this in the X by -90, and this will be our top face. So this will be, let's make it green. So I have this red, blue and green. How do I make a box from this red, green and blue plane? What I can do is, it's 7:30. So I am going to go a bit faster, but I'm going to try to complete this by 7:45. So first of all, this green plane, let's rename all of this. So my red plane is plane 3. I want to rename it and call it front face, FF. The plane 5 is the green plane. That's going to be my top face of the box. So I'm going to rename and TF. So I think it will be visible somewhere here. And plane 4 is the blue plane that will be called so red, blue is the right side, so right face, RF. Okay, so now see, I know that the dimension of each of these boxes are 0.5. So if I move this so this entire thing is 0.5 units. So this unit is what? Is 0.25 units. So if I move the right face in the X by 0.25 units, that makes a box. That makes one face of a box. Select your top face. We need to move it 0.25 units in the up direction. So Y 0.25. And the red face will be the front. So in the Z direction, 0.25 units, move it forward. See, now from this angle, it looks like I have a box, right? But from here, these are empty. So we need a left face and a back face. Simple. Clone the front face, FF, and move it in the Z by negative 0.25 rather than positive. Okay. So I have a face here, but its color is not visible. You can go to its material side and make it back side. So now I have a red front and red back face. And similarly, I'm going to create a blue left face. So first of all, FF2, rename it to back face, so BF. And the RF is the right face. I'm going to clone this and rename this and call it left face, LF. So its position is going to be what? So rather than 0.5 units in the positive X, 0.25 units in the negative X. So minus 0.25. And again, same thing, material, backside. And now you see, from all of these angles, don't look from the bottom because we don't care about the bottom. We want our app to be optimum. We want our app to have good performance. So right now we have this entire box that is made of planes. Okay, now you will see this box is at zeros. It looks to be halfway below the ground. See, you can check from this grid. So what we'll have to do is we'll have to move all of these planes 0.25 units top. So FF also moves 0.25. Yeah, FF moves 0.25, back face moves 0.25, top face moves 0.25 plus 0.25, 0.5. Right face also moves 0.25. We'll just need to keep, there are a bit of calculation involved, but just simple subtraction and multiplication and addition that everyone can do. So now I have a box. I have a box that is made up of 5 planes. Let's make all of these invisible. And first of all, let's make detect cursor event to be true. We can uncheck collide with player. Okay. And detect cursor event true. So now let's make all of them invisible by default. You'll see why. So once I have done that, yeah. So see, my original box is not visible anymore. What I can do is I can go to code now, and I simply have to define that just like whenever my cursor entered, I'm saying that move the red transparent box to the cloned object's position. Remember, I showed you cursor has 3 events. It can enter an object, it can leave an object, or click on an object. So here, similarly, I can simply define that cursor on click at object. So after cursor on entered object, I just define cursor on click at object. I'm going to have this on the top here. So cursor on click at what object? on click at any of those cloned planes. So cloned object, and what do you want to happen here? So I don't want to define the entire code of adding a box inside this. I can just say create box. I can just name a function here, create box. Okay, and I will create another function that creates the box. All right, so now whenever we are creating this box, we need the XYZ position of that planes that we have, right? So because based on that, so we'll position the new box that we are adding. So it will need 3 inputs, the X, Y, and Z position. So we will this will tell us where to create the box, the X, Y, and Z position of that new box that we are adding. So just say create box, and what it needs 3 inputs. Let's give it X, Y, Z variable names for now. We will modify this. Okay, so it basically it needs 3 inputs. The 3 inputs that it needs here is cloned object dot get X, the X position of cloned object, X cloned object dot get Y, the Y position of the cloned object, and cloned object dot get Z. Okay, and here I'm going to define 3 inputs, U, V, W. Okay, so U, V, W are going to define where the new box that we are adding is going to be placed. And now it's very simple. Inside the create box function, what's going to happen? We are going to go to utilities again and select this clone object function, close this black box, delete this without a callback function. So create box, what happens here? So we are going to clone all these front face, back face, top face, right face, left face. Every time we click anywhere in the game on top of any of the planes, we are going to clone these 5 planes that we created like a box and place them in place of that red box, and it will look like a new box has been added. Okay, so let's do this. On the top of our code, I'm going to create a variable called faces, and I'm going to just go through. So front face, back face, top face, right face, left face. Okay, so I'm just creating an array of all the original faces that I have. So the reason I'm doing this is now I can just, inside my create box function, I can create, say, a for loop for let I or let f of faces. I can just iterate through all of the, so let I is equal to 0, I goes from 0 to, so what are the indices? So 0, 1, 2, 3, and 4. So I can just say 4 here, and I plus plus, so less than 5, less than equal to 4 or less than 5. Okay, and now inside this for loop, so we are going to basically clone 5 faces. So we are going to run the hatch.cloneObject function 5 times. So we are putting that inside our for loop. Easy. And now see, hatch.cloneObject, what object do you want to clone? I want to clone whatever index it is. So whatever value of I, so faces index I. So we are going to, so if I is 0, then it will clone the front face plane that we created. If I is 2, then it will clone face. If I is 1, it will clone the back face. If I is 2, it will clone the top face. If I is 3, it will clone the right face. And when I is 4, it will clone the left face. Okay. And now we need to define the positions of those faces. Okay. So now this is easy. So this is easy. This is easy. I'm just thinking about the positioning. So here I can simply say, based on the XYZ positions that we are getting, we can just because XYZ position that we'll be getting is of the planes, but of these planes as well. I'm making a small mistake. I don't think I'm making a mistake, but there would be a slightly easier way to do it than what I'm going to do right now. But let's go ahead with this. So clone the eye face, and then I can say if I is equal to 0, then so I is equal to 0, then I know that the front face is being cloned. So front face needs to have an offset of Z, right? So from the boxes position, yes, yeah, fine. So from the, yep, let me see, the stream is working fine. Okay, so from the boxes position, let's go back here. Here I can just say clone object name, we can say box.getX. This was why I was a bit confused, because rather than, we can modify box's position wherever we want, but based on the box we can offset the planes. We know what offset the planes need of 0.25 plus minus. So box.getX, get y, get z, and this will now tell us so if I is 0, then clone object, so clone object dot set z to u v w x y z. W is the z position, w plus 0.25. okay, else if I is equal to 1, then the back face is being cloned. Now it's just a lot of if-else conditions, that's all, and your project is done. I'll show you. So clone object dot set z to w minus 0.25. Remember, when we were creating those planes, we were positioning front face forward 0.25 units, and we placed the back face behind 0.25 units from the 000 point. So that's all we are offsetting here as well while cloning the planes. Otherwise, so if we are not cloning the front face or the back face, then for all the other faces the z is going to remain as w. Else clone object dot set z to w. Okay, so now we did this for front and back. We need to do this for left, right, and top as well. So copy the entire code. So if I is 0, if I is 3, okay, so that means right face, right and left, 3 and 4. okay, so if I is 3, then set x to u plus 0.5, right? And if I is 4, then set the x to u minus 0.25. U is the x value, box.getX. Otherwise, set the x value to u as it is. Okay. Now for top face, it's very simple. If I is equal to 2, then say clone object dot set y to be v plus 0.25, else if it's v. So else clone object dot set y to v. Okay, so we have one section of our code ready, this create box. Okay, now what I can do is let's see if this runs or not. So run script, and oh, I made a mistake. All of our planes are invisible. So clone object. Once the object is cloned, what I can do is cloned object dot set visible to true. Okay, so I added another line of code that says, so I think if my head is obstructing some of the code, then I'm just putting it like this. Okay, so I added this line of code. So because all of our original faces are invisible, we need to make sure the cloned faces are visible. So we have to turn on their visibility. Let's run the script again. So now when I move my cursor here, see, my cursor's position is detected by the red box. And now let's click. Okay, it's not happening. I'll tell you why. It's because see, my cursor is right now facing the red box and then the plane behind it. And what's happening is when I'm clicking, it's the clicking is being detected for the red box. Okay, what I can do simply is I can just go to the design tab. The clicking will always be detected for the object on the top, on the very first. So for my box, I just need to disable the cursor event. And no shadows as well, no collide with player, nothing. Now everything should run fine. Fingers crossed. Okay, so I'm able to click see, easy, right, and see if I move around, I added 3 boxes. See, I added 3 boxes. It looks like I have added 3 boxes, right? And now I can add more boxes. If I click on any of these spaces, then you see that a new box is getting added, right? You can change the color of the box. I'm just using red, green, and blue because each of those faces are easily distinguishable. And perfect. So now I have this voxel painter, but right now you see I'm not able to detect the. So what I want to do is I want to be able to attach boxes on top of each other. So what I want to do is when I move my cursor on top of this green face, then I also want to place the red box on top of the green box. Very small addition to the code. I'll show you. So this is where we are creating all of these faces. Function create box. So once you have made them visible, all we need to do is attach cursor on entered object and cursor on click at object, just like we did for the plane. That is it. And your voxel painter will be ready. I'll show you. So cursor, once all we needed to understand was how does the app work, okay? And after that, the entire logic is very simple. It's a bunch of if-else statements and some functions. That's it. So cursor on entered object, on entered which object, on entered these cloned objects. So clone objects, okay? And what should happen? So let me go down so that the code is visible for all of you. Okay, and I think, yeah, this is fine. So cursor on entered cloned object. So I'm going to say if. So I'm going to say if again. So these conditions, right? I'm just going to copy paste these conditions from the top. Control C and paste. Actually, let's write them properly. So if my cursor is hovering over a front face, so if I is equal to 0, then box dot set x to front face an offset of 0.25 in the z unit. That's it. So box dot set z to cloned object dot get z plus 0.25. okay, and then we just So from the front face, the red box that needs to be placed has to be 0.25 units offset in front of it. Okay, so simple as that. And then I told you just a bit of maths on understanding where the, not even high level maths, simple addition subtraction, because I know my planes I made 0.5 to 0.5 units length and width. So if the center is the position, if we are defining the position from the center, then the left and right and front and back are 0.25 units apart. That's all we are doing here. We are placing all the faces 0.25 units apart from the center. So front face is positive 0.25 units offset, and the back face will be else if I double equal to 1 box dot set z to cloned object dot get z minus 0.25 units. Okay, so for front and back faces only the z position will be offset, and for other faces the z will have no offset. So else box dot set z to cloned object dot get z, and we do the same thing for x as well. So left and right faces, and for those the index I is varying between 3 and 4. So copy paste this line of code again, and what I can do is, yeah, so I have I, if I is 3, then box dot set x to clone object dot get x plus 0.25, and if I is 4, box dot set x to get x minus 0.25, else it's get x. And for top we need just I is equal to 2. So if I double equal to 2, then box dot set x to cloned object dot get, set y. The top face will offset the y position. Set y to get y. I should have used the whiteboard to show you guys what the maths of this, but I think once you guys work on the project, everything will be self-explanatory. 0.25. Okay, else, because there is no bottom face, so we don't need another else if condition here. Else box dot set y to cloned object dot get y. Okay, so what I'm doing here is when cursor enters any of these red, green, blue faces, then also that red box that we have, which has the name box, we are placing the red box based on which face is my cursor looking at. The green face, the red face, front face, back face, right face, left face, or top face. So if my cursor is looking at the front face, so front face has the I index 0 here. This index of FF in this faces array is 0. Okay, so if I is 0, then the red box will be placed 0.25 units in front of it. And if I is 1, that means the back face, then the red box will be placed 0.25 units behind it. Okay, run the script and let's see if it's working or not. So now every time I add a box, see, there is some error, but we will be able to debug those. So if my cursor moves on the blue face, it's positioning perfectly. If my cursor moves on the red face, it's not positioning perfectly. Okay, so red is the I3 and I4. All right, makes sense. We'll have to understand what's happening here. And so top face is also having some issues with the numbers. And the back face, let's see if the back face is working perfectly. So back face is also not working perfectly. Okay, and the left face, so left and right are working perfectly. Yeah, but the top, front and back are not. So left and right are working perfectly. So this is fine. Now I found my error here. So left and right. So this has to be set X to get X. Set Y to get Y. So cloned object, and let's see once again what's the error. So if I add a box here, now, okay, so perfect. Now it's, so I had made one error of here saying box set Z to clone object dot get X. That was making all the issues. That was because of that I was having the issues. But now you see, so when I'm looking at the blue face, a red box is placed in front of the blue face. Same for the red face, same for the green face. So now what I can do is when I click on the blue face, I want wherever this red box is positioned, a new box to be added. So that is very simple. You just say cursor on click at object, and what do you want on click at which object? Cloned object, and function, just say event, and here we define what happens when cursor is clicked at these clone objects. So what we just want to run this create box function again, so we don't have to write any new code. We just say create box. Actually, you will see I'm not writing any new line of code. I'm just copy pasting this line of code. Control C. So create box at the box's position. Run script. And now 1, 2, 3, 4. See, I am able to create my own 3D objects. So I can place wherever, I can place my boxes wherever I want, right? And the fun thing is you can run this in AR. There is no other design elements, so you will only be seeing that white grid, and anytime you click, a new box will be added. This is, see, I am just clicking and I am building a staircase that is coming towards me. Let me show you a 3D staircase that was going towards the player. See, how cool is that? Now I have not explained the logic of how can we delete faces, delete a box, okay? But that's also very simple. That's very simple. Okay, so it's 8 o'clock, and I think what I can do is I would like to end the session here, because we have completed the basic part of what a voxel painter is. And as I said, the final output with adding and removing boxes is available in the final output as well. I can do another session where I show you guys how to, delete boxes in the voxel painter, or you can refer to the final output as well, or you guys can reach out to me on Discord and I can help you guys learn directly from there as well. Okay, I'm just going to publish this. So voxel painter 001, and I'm publishing this. So if you guys look at the gallery right now, yeah, if you guys open up HatchXR's gallery, you will be able to find this project, or I'm just going to send the link of this in the YouTube chat, so you guys can have access to this project's link as well and learn it from there as well. All right, cool. So yeah, we have completed basic stuff of what a voxel painter is. What you can do is you can increase change the small box's size to small, very small, and increase the number of this grid that you have. Right now we have 11 cross 11. You guys can have it from like 20 cross 20, a 400 squares grid, or you can make it like 50 cross 50. But just know that the larger number of squares you have, the slower it might take, the more time it will take to load and perform. Okay, so that is why I did the whole thing with lesser number of squares. But you guys are free to experiment it from your own perspective. Add, you know, as small boxes. If you make the boxes small, you just have to change the numbers wherever I'm saying 0.25 to half of whatever your scale is. Okay, those offsets you'll have to just manipulate. Other than that, the entire project is hopefully useful to you guys. And yes, any questions, any queries, reach out to me on Discord and I will message you. I'll help you guys. All right, cool. Bye bye. See you guys.